Okay, good morning. It is February 5th. I'm streaming, but the class doesn't know that yet. So we are here. And let's head over to class. Currently set for sunset because it was last time I taught was last night. We'll adjust that in a second once we're in class. Kind of excited about class today. We got some good stuff lined up. I'll look over, I see some of the students are already here, but they are in the classroom where I should be. Morning, everyone. Good morning, everyone. I'm double broadcasting at the moment and setting up our screen with a current broadcast for today. All right, it is currently February 3rd. Wednesday, this is CS-030. Wednesday, Okay, that's horrible. All right, let's see. So I do believe that the screen is set up now. It should be broadcasting to you all okay. Let me just double check that that's accurate. Today is February 5th. Can someone, I'm double broadcasting at the moment, but can someone in the classroom here confirm that they are experiencing a good YouTube video?
Yeah, we can see it.
Okay.
Yeah, I can see it.
All right, so let me turn down the music for a sec. All right, good. All right, let's run through our checklist real quick. I always have to do this because I've got so many moving parts, so I'll help you guys to do it as well. Find a quiet location, tell your roommate you're in class. Let them know that even though they are addicted to some new smoothie subscription service, they have to stop making smoothies while you're in class so you can hear. Put on your headphones so you don't get echoes throughout the world. Make sure your mic is on. That's a side bit. Turn down any extra apps or browser tabs you have. If you're playing League of Legends on the side, now would be a good time to put that into pause. If that's even something that you can do, I don't know. Open Canvas so you can see what we're working on today and what we have for assignments. Make sure your VPN is on so that your audio is working all right. Once your VPN is on, restart Firestorm and arrive. Make sure you remake your avatar, something I got to do right now. Go under Avatar and Avatar Health and Force Appearance Update. Let me show you what I'm looking at meantime. After we do that, we set our environment to be consistent. Last time I taught was last night, so we set our world up to be evening in the evening class, but today we'll go to midday, so everything should brighten up here. That's better. Okay, set our draw distance to a low number. When I'm going around the world, I like to be able to see far away, but when I'm maneuvering in class, I need my draw distance much lower so that I get better performance. But it's good to be able to see the back of the building as well. So I set mine down to 120, 200 today. Make sure you make it to the classroom. Looks like you're here. Make sure you can see your classmates' names so that you know who's talking when they have little bullets over their head. Let's look around and see what else we've got going on. All right. So for this class also, make sure you've got Eclipse open and that you've connected to Saros. You should see me there right now. Let's make sure that's right. Show you a glimpse of that. I'm online. I see 3 of you online. We're going to be using Saros pretty extensively today, so let's get that going because that's going to take a little bit to sync. A reminder that over on the right side, over here, we've got a shelf that has some documents on it, including solutions to 1 and 2, problem set 1 and 2. You guys, which I haven't returned to yet. I have a few more to grade, so apologize for the delay in that. Look around the class, see who's here joining us. I see Ben. Good morning, Ben. Good morning, Trent. Good morning, Dee Dee. Good morning, Frank. Good morning, Sam. Good morning, Thomas. Good morning, Matthew. Good morning, Adeline. Pulling up my chat so I can see questions that you put in there. Let's head over to the other side. Morning, Ethan Vaughn. See you arriving. Morning, Ethan Banez. Your outfit looks stunning. Good morning, Faith. Good morning, Landon. Good morning, Carson. Morning, Ben. Morning, Morgan. Morning, Josh. Congratulations on your internship. I saw you announced on LinkedIn. That's great. Good morning, Ben. Ben D. All right. Let's open in a word of prayer for a second. Acknowledge why we're here and to the ends to which we've been called. Pray with me. Dear Heavenly Father, thank you for this technology that allows us to meet from all different places and to some degrees, times. Help us be grateful for that. Help us be grateful for this COVID vaccine that's helping us to get through this difficult time. It's really phenomenal to have a vaccine that's 95% effective, multiple options generated in under a year. That's never happened in the history of the planet before, and that's phenomenal. And we're grateful for that. But we also recognize that it comes too late for some people. Some people are currently sick. Some people have people close to them who are very sick. We pray for their health and for the continued strength of our community. Pray for our ability to learn Java today. Something that I get very excited about. I can see the way in which our Imago Dei, the way in which we are made in your image, we carry out those qualities through the work that we do. Help us do that faithfully. Amen. Okay, great. Let's take a look at our calendar. Make sure we're all on the same sheet of music. I'm tearing up because that's the way I roll. So stand by for that. All right. All right, we're looking at the calendar. And it is today, it is February 5th. Let's make sure we're looking at the right class by selecting over on the right. You've got a programming assignment due tonight. That's the letter class and the letter printer class. You're creating 2 classes that are, one is you're the implementer and the systems programmer, and the other you're the API programmer, writing the letter printer class that uses them. So together you're writing 2 classes with 2 different hats on at one time. Exercising that interface idea where the person who's using letter printer, the methods that are in letter printer only access the public methods of the letter class. And by creating the letter class as a systems implementer, you are creating a tool that your letter printer can use. Some of you have raised a question about how much commenting there should be because I'm very happy that you guys are attentive to comments because it's very important for professional software development. It's important for you when you come back to your code 6 months after you wrote it and you can't figure out what the heck you were thinking. So we're learning how to do a good set of what the good coding practices are, and today we're going to look a little bit more in depth in that with JavaDoc, which is a little tangent from what our book is covering this chapter. All right, great. Chapter 3. Any questions or comments before we get rolling on that? Looking over in game real quick. I am double broadcasting, thank you. I am now single broadcasting on YouTube. I am now single broadcasting on YouTube. I'm about to single broadcast on YouTube. Keep me honest on that. Okay, where do I want to begin? Let's begin by setting up our Saros session. So I'm going to switch over to Eclipse and hopefully find some of you there on Saros. Let me get there. And we'll connect our code together. Rearrange some windows here. Great. All right, so I see a handful of you. What I'm going to do is I'm going to share a project that just has one particular demo class in it. Let me clean up that demo class because we're not ready to look at it yet. It has just a main method in it, not sharing yet. All right, here it comes. Ready? Sharing. Whoosh, here it comes. You should be getting invites now. All right, and shortly after we settle down, I'm going to put everyone into read-only mode so that as you type, you're not editing the code that everyone else is seeing, although that's a feature of Saros. For the purposes of teaching, we don't want that to happen right now. All right. All right, waiting for a few people to accept invitation. Ben Fernberg, looks like we're synchronizing. There we go. Great, things seem to be moving a little bit smoother now that we've cleaned up some of your all's firewalls, although I think some of you, um, everything okay, broadcasting wise? All right, let me clean up what we got. All right, for those of you that are currently connected on Saros, I'm going to go ahead and shift you to read only so that I can edit without having you guys conflict with what I'm doing. It's going to take a second to roll down here. All right, so I see Adeline, Ben Fernberg, Ethan, Faith, Landon, Dee Dee, Morgan, and Thomas. And we'll go through one more time for those of you who weren't online when I did my first hit. As soon as we connect here with Thomas, we'll do a second round, and then if the second round doesn't work, I'll have you guys connect with me during office hours to probably correct your firewall. Just wait a second for Thomas's computer to agree. Thomas, I wonder if did we fix your firewall, Thomas? Did we do anything with it? Okay, Ethan, I'm going to re-add you. Frank, I'm going to re-add you, or I'm going to add you. Okay. Oh, yeah, yeah. So that's a good point. Thank you for pointing that out. If you use your glasses over here, you can follow me, and hopefully that won't break your connection. Thomas sort of indicated that it did, but maybe. Looks like you're connected now. All right, I'm going to wait for everyone to settle out. All right, Frank, I think we're going to have to connect during office hours because something is consistently breaking on yours, and that's probably. Oh, no, wait. I'm not sure if you're here or not. All right, waiting for Ethan and Trent. All right, Sam and Ben are restarting. Ben Ehrenchild, I'm going to connect you. Ethan, I'm going to connect you. Uh, I can hear you, Frank, but I can't answer because of the lag in YouTube. So go ahead. I mean, I guess assuming that was Frank. All right, let me do a pass through where I set the appropriate people to read only who have just been added. Good. Looks like Frank's connection dropped, maybe. All right, setting to read only. Setting Thomas to read only. Yeah, so I think something that happens is that if your connection drops for some reason, we should check over office hours what's going on. But you appear to be still connected, and then when I try and make you read only, my computer realizes that you're not answering for whatever reason. All right, I'll do one more pass against my best judgment here. By the way, I did check on the software for Saros, and there isn't an upper limit on how many people can connect. Any place where there's documentation about there being a limit on how many people can connect, that's actually a limit on how many people can connect to the server in Berlin. So as long as we're connecting over our OpenFire server, the software itself doesn't restrict a certain number of people. All right. All right, so the first, well, let's just settle out. Eager to get going. Let's just let this settle out. All right, my software says waiting for Trent to choose a project location, but that could be outdated, and waiting for Sam to accept an invitation, but that also might be a computer block, not a human block. All right, I'm gonna go ahead and, there we go, great, great. All right, waiting for Sam to pick a location according to my software. Great, we're synchronized. All right, let me do one pass on read only and then we'll move forward. All right, we are getting better at this, you guys. I'm happy about that. Good, great. All right, super. All right, a few of you haven't connected yet. We're going to have to move on though. All right, so the first thing that I want to do is I want to introduce the idea of JavaDoc because commenting is a concern that's come up several times, both in my grading, but also in the context of just figuring out what is appropriate to have in terms of comments. So what I'm going to do is I'm going to move our classes from last time into our new, let's see, I'm going to move the code that we wrote in our previous class session into the current project that we're executing. And so you should see 4 different new classes show up, and I'm going to delete demo. So we've got our amount test, our bank account, and our bank account test. Checking in. Okay. All right, so let's take a look at our amount for starters. And commenting, you should always have a comment at the top of your class. And so for starters, we should have the provenance of the file for the purposes of turning in something for homework. You should always have your name and the date and the assignment at the top. This is not in the context of an assignment, so I'm not going to write comments as if I'm turning in an assignment. I'm going to write comments as if I'm commenting this for usage. So we know from our reading that there are two kinds of comments that have been introduced. One is the kind of comment that starts with a double slash and is a comment to the end of the line. And the other kind of comment is a block comment that starts with a slash star and ends with a star slash. And that can be multiple lines long. And Eclipse is putting in these extra stars in front of me for formatting. These extra stars on line 4, 5, 6, 7, 8, 9, those aren't relevant to the interpretation of this as being a comment. It's just there for style so that it looks like it's a comment. What's important are these first two characters and these last two characters. All right, so this was a little bit of a hand wave because there's actually a little bit more to comments than just these two types of comments. There is a markup language associated with comments in Java called JavaDoc, JavaDoc. This is actually one of 3 different skills that I would like you to develop in working with Eclipse. The first skill is JUnit testing. We looked at that a little bit. We looked at how we could do code coverage to see JUnit testing. A second skill I would like you to know is how to write JavaDoc, which is formatted comments. And the third skill that I want you to know how to do is to use debugging in Eclipse, which we have talked about with some of you in office hours, but we haven't had a time in class to talk about it yet. Eclipse is a full-featured integrated development environment that is abbreviated as IDE, IDE, Integrated Development Environment. Eclipse is an example of that. Xcode is an example of that on Macs. IntelliJ, Android Studio, Microsoft Visual Code. There are all kinds of different IDEs. Eclipse is one that is cross-platform, cross-language. Debugging is one of the features that most IDEs offer. So to talk about our second skill here, this JavaDoc skill, I want to introduce a slightly different way of doing comments. We've seen it briefly, and that's to, if you start a comment with a slash star, that makes it a comment. If you add another star at the beginning of the comment, that means that the comment will be interpreted as JavaDoc Markdown. It'll look for a particular format of the comment and be able to publish a document based on that. And that's what we're going to look at here right now. If I start with slash star star and I hit enter, Eclipse recognizes that I'm intending to write a JavaDoc comment and will proceed to write as much as it can in that comment based on what it sees in the first line of code following that starting comment. So when I typed the slash star star, it looked at line 16 and tried to generate as much of a comment as it could. So let me clean up what's there. And I'm going to add a comment here and say what this class is about. And this is a standard level of commenting that I would expect from any code that you turn in and also any code in a professional environment. So the amount class keeps track of a wallet with dollars and cents and is useful because it doesn't round off fractional cents. Okay, so that's an overall look at what the class does. DJP3 might be helpful for some of you, but I'm going to go ahead and put my name in here as well. And then DJP3 is sort of my Twitter handle and whatnot. Now you can't use an @ because if you use for a Twitter handle, unfortunately, because if I add an @ in there, it gets interpreted as JavaDoc. The JavaDoc markup starts with the @ character. So this @author here is going to tell JavaDoc that what follows is the author of whatever I'm marking up here. Notice that the end of the JavaDoc comment doesn't require the star star slash. What ends this comment is the star slash. What starts the comment is the star slash. What indicates that it's a JavaDoc comment is that it's star slash slash. Now, if I wanted to end it with another star, that's fine, but that star is just part of the comment. It's not giving any information to the processor about what's going on. So I've clarified that. Here are some private instance variables. So that's not part of the public interface. So any comments that I would put would just be for the implementer or the system programmer. I could do that here, but it's sort of obvious what's happening here. I don't feel like that needs any additional commenting. Here I've added a JavaDoc comment on the constructor. I've used the JavaDoc syntax and I said construct an amount object with 0, and and it continues on the next line with $0 and 0 cents. So that clarifies what the constructor is doing. I put this here for your purposes to understand what's happening, but you can assume that people who are reading your code know how Java works. Even if you're learning it, eventually you don't need to put comments in that describe what the language is doing very specifically. What you want is slightly higher level comments that communicate what the programmer's intent is. So your class should be commented, and then every method should be commented as well. And what you'll see is when you start a JavaDoc comment, for example, when I did this one, it went ahead and filled out the parameters here for me, and we'll see why that's important in a second. And so the way I commented this is I said, construct an amount object with a specified balance. All right, good. And here's how I describe this. Dollars, the starting dollar amount, and cents, the starting cents amount. Fine. All right, I don't have a comment for update. This is the one that we improved last class by introducing the integer division and the integer modulo. Let me refresh you on that. When you use the division sign, the slash, the forward slash, whether you're doing integer division or floating point division depends on the arguments on the left and right side. So on line 36 here, we're doing an integer division because there's 100 on the right with no floating point, and so Java will interpret that 100 as an integer. And on the left, we have a variable, the instance variable, this.sense. When we look at its type, I'm going to, let me zoom in so you can see the code a little bit better. See what the comment was over here. Okay. When you look at the type of this.sense, I can hover over it to figure out what it is. It's an integer. So I have an integer in the numerator and an integer in the denominator. So this will be integer division, which means that the fractional component will be discarded. That's what I want in this case because I'm trying to figure out how many dollars are present within the amount of cents that I have. And I want to increment my instance variable by the current number of cents because what update is doing is it's kind of shifting everything to a lowest common format. Or, you think about it like lowest common denominator in a fraction, but it's similar to that in the case of the dollars and cents. So I'm going to siphon off all 100 chunks of 100 for my cents, and then what I'm going to be left over with is whatever was left over when I divided by 100. So I need a comment for this public method, and so I'm going to start with a JavaDoc notation, and when I hit return, I'm going to get a little, it's going to get filled out for me. And so I'm going to say this method converts the balance to so that cents is between 0 and 99. And the value in the amount remains the same overall. Okay, so that's pretty good. Finally, we've got a getter down here. Let's add a comment for that. Return the number of dollars in this amount object. Can't type, object. Okay. All right, let's do one for get sense. Number of cents in this amount object. Great, and then we got to do one for add. Let's see, we're going to combine two amounts by adding them. The amount to add to this object. The balance of this object will be increased by A. And then it goes a little too far, so I'll cut over. Good. And then for subtract, I'm going to do that. I'm going to copy this comment because we're just going to convert it a little bit. So decrease this amount object by the balance, by the amount in A. And we need some information about how that is going to affect things. This object's balance will be decreased, but A will not change. So that's important to have sort of statements like that about how it affects decrease. I'm getting spell check errors there. Good. The amount to subtract from this object. All right. Hopefully that's it. Okay, and then this last one is a private method. So this might be helpful for me to know, but it shouldn't, there's no reason to have a JavaDoc comment on it because the primary reason why you have JavaDoc comments, well, you can do a JavaDoc comment on it as well. Um, this is an error check that throws an exception if this object's balance is less than 0. All right. Okay, and then I want to do a similar set of work for my bank account. I want to add some classes. I want to add some JavaDoc comments here. This class keeps track of a bank account and the money in it. Author, update my author. All right, this is going to be private. I'm going to make that explicit, and I'm going to create a bank account with 0 money in it. Great. Deposit some money in this account. A is not modified. The amount to add to this account. And withdraw. Withdraw some, sorry, come on keys. Withdraw some money from this account. A is not modified. The amount to withdraw from this account. I don't want 2 copies of parameter there. And then finally, return. Notice that you get this return statement for any method that actually returns something. We don't have return in the other ones because it returned void. So return the amount in this bank account. And I'm not going to put any other comment here because it's called get balance. It's a bank account. Like if you can't figure out what a bank account method called get balance means, then like the issue is not my comments. Okay, so that is the key thing that is necessary for us to generate JavaDoc. So we've gone through this work of doing a good job of commenting and describing how our classes work together. You can see that I focused my comments on the public interface and I didn't put any comments on the testing classes. You can put comments on the testing classes. Those would be comments for the systems programmer though, because external clients don't use the test classes. Those are just for development purposes. It's very important that you document the interface for your class, though, which are those public methods of your class. Now, the reason why this is good is because in professional software development, you want to be able to publish the documentation for this. And so you can select your class here. You can generate some documentation automatically now from the markup. And the way you do that is you go under Project, and you go down here where it says Generate JavaDoc, Java documentation. And we click that, we're going to go through a series of wizards. We can read this carefully. It asks us what the JavaDoc command is. That means that there's a program on your computer that's going to do this for us. It should come installed with your software, and you can find it if you want. That's good enough for me now, even though it's from a previous JDK that was installed, not version 11 that we are working from in this class. Next, you select which projects and which type you want to document. So I only want to document the project that we're working on today. I'm going to open up this accordion. I'm going to open up the accordion for source. I'm going to open up the package, and I'm going to select the package so that I see which classes over here are going to be documented. I'm not interested in documenting the testing class. I only want to document those things that are relevant for people using our software. So I'm going to uncheck these, and those will not be in the documentation. I'm going to create Java documentation for those public methods. That's because I'm generating this documentation with users in mind. I could be generating this documentation for me if I wanted to, in which case I might include these other ways of specifying visibility of our methods. Thank you very much. Great, good catch, thank you. The public visibility, Right here where it says use standard doclet, what that's talking about is there's a template for how these documents are going to be generated, and it comes, you get one. Well, do you get one for free? What am I using? I thought I got one for free. Oh, yeah, yeah. So use standard doclet just means use the template that's built in. And then this destination is where do you want your documentation to end up? And I'm going to put this documentation into this project in a folder called DOC for documentation. Hit next on my wizard. What's the title going to be? The bank account details super duper documentation. That's just going to be in the document. Bunch of check marks that you can check for different things you want included in your documentation. You can include hyperlinks to other projects as well if you want to do that. I'm not going to do that for the purposes of today. Select next. A couple specific arguments for the JavaDoc program if you want. Here's the only thing I'm going to be specific about checking, which is open generated indexed file in browser. What JavaDoc is going to do is create a website for me that has the documentation. And by checking this, I'm saying, hey, please open a web browser within Eclipse that shows me the contents of the documentation. And now I'll hit finish. Give it a second, and the documentation folder appears. Hopefully that's getting shared with you all. And you can open that up and you can see that it's created a website for us. You enter into this website by opening the index.html file, which is being shown over here in the center browser. And you can see that I have all the classes that I wanted documented over on the left. And when I click on one, I get details in the frame on the right. So if we look at the amount class, you can see that it's taken the Java code and it's created a very nice documentation for this. It says that this is the public class amount. It is descended from the object, from the Java language object. It inherits from there. Here's the instructions about the constructor. You can construct an amount object with $0.00 by calling this constructor. You can construct an amount object with a specified balance by calling this constructor. Now, where is this coming from? Construct an amount object with a specified balance for the amount object. Well, that's coming from this JavaDoc right here. Up here, when I specified it in code, construct an amount object with a specified balance. Hello, everyone. Doesn't make sense to put this in your code, but just to demonstrate what's happening, I'm going to go up here under project and generate the JavaDoc. Just going to hit finish right away. Come back here, refresh it. Oh, something happened. Something went wrong. Oh no, I must have just opened the wrong one. Let me just reopen it over here. I'm going to go under doc, double click on index. Something must have gone wrong when I generated it. Let me be a little bit more careful. Generate JavaDoc. Open this, select here. There we go. There we go. Now we go to amount, and you can see that the website is including that. And there's the hello everyone from there. It's all linked out, so if I click on the amount, I will jump down to details about this. And here, when you click on the details, you see public amount, there's dollars and cents, and you can see the parameters are listed here, the starting dollar amount, the starting cents amount, so that you can look at this document now and you can get a sense for how this class is supposed to be used. And what's great about this is it's not a separate document that you're writing. It's not some other website that you have to write all the time. It's a website that's generated from the code, the comments in your code. So as you write your code, if you do a good job of documenting your code with JavaDoc, you don't have to write separate documentation. It gets generated automatically for you. And when you see this format now, you're going to recognize that it's from JavaDoc. So for example, if we were to go now and we were to go to, let's go to sort of the official website for standby. Oh, shoot. Okay, am I broadcasting okay? Sort of. Okay. And we go to, let's look at the Java string documentation on Oracle website, Oracle Java 11. See what we get. All right, docs, Oracle, com, string, JDK 11. That looks good. Show up here, and lo and behold, look at what we've got. We've got something that looks just like a JavaDoc. Here's the constructor summary, the string, all the different constructors that you can have for a string class. What's going on here is that we're looking at the comments that are in the actual Java string software. The source code are being generated, has documentation in it has JavaDoc comments in it that are the source for this documentation. So you can see that just professionally, this is just something that's done all the time in order to keep accurate explanations of what the code does. If you go over to overview, you should get all the different packages. This is, if you get deep into JavaDoc, but let's see, stand by. Let me see. I want to go to the top here. I want to go to the package, Java language, and you can see a bunch of different views of this as well. So you can click through, and all this is just generated by the software, which is great. All right, so for today, what I'm going to do is I'm going to delete this. Today, for your sort of daily work for your participation, what I'm asking you to do is, after we've broken the session with Saros so that you have the ability to edit this code, what I want you to do is I want you to go into the software for today. I'll leave bank and the bank account and the amount class present. And I want you to change the classes so that it looks like you're the author of the classes. Okay, you're not the author, but for the purpose of just teaching today, I want you to set it up so you're the author. And then I want you to run the JavaDoc program, and I want you to produce the documentation. And I want you to then screenshot the view of the documentation after it's been created by JavaDoc such that it shows your name in the documentation. Take a screenshot of that and submit that for today on Canvas. So that should be straightforward once class has broken and you have the ability to you have the ability to write in this class. Let me take a breather there about JavaDoc. Any questions that you have about that? Anything you want to ask before I move into our next topic? Again, this is skill number 2. Skill 1 was JUnit testing. Skill 2 was JavaDoc. Skill 3 is going to be debugging when we get there. Okay. You're all happy? I'm happy. We're happy. Happy class. All right. So the next thing to do then is let's shift gears and go back to chapter 4. And I want to run through some of the more of our chapter 4, which is about our fundamental data types. Fundamental data types being those data types that have lowercase letters, and we're also counting string as being a fundamental data type. So let me make sure that I am broadcasting our slides. Whoop, whoop, whoop. That's the noise. You may not be familiar with that noise. That is the noise. There it is. Okay. And let's make it a good size. That's another noise. And great. So I'm arranging because windows on my screen change size, and because I am sharing those windows, I have to realign them in the broadcast so that you can see the slides on the screen. And then I also want to make my face obscure as little as possible, because as much as I'm narcissistic and love to see my face, that's not effective teaching. Okay. Good, here we go. All right, so I'm monitoring, what I'm broadcasting right now is slides for chapter 4. I'm monitoring chat in class, and we're temporarily not using Eclipse. Okay, so we left off talking about these arithmetic operations, and we looked at integer division and integer and modulo, which is always an integer result. And we augmented our amount class so that we would use this to effectively reduce our dollars and cents to the lowest possible number of cents and the highest possible number of dollars, such that the amount was the same before and after. Moving on, there might be more elaborate kinds of mathematical operations that you might like to have access to. That's a typical thing that you do with computing, is you do some math. So there is a class called math with a capital M that's part of our Java language package. So it's part of the default software that you get. It is primarily a static class. So all the methods in the math class, I think all of them, are static. And so you don't need to create a math object in order to use them. You just need to get to them through the math name, through the capital M math class name. So an example of that is the square root method. So the square root method, abbreviated as SQRT, squirt. The opposite of that, the power method, so raise something to a power, POW, pow. Those are two methods that are present in math. If we would like to take the square root of a number, we can say math.square root and treat that as a method and pass it the value that we are interested in taking the square root of. That looks like the slide demonstrates. Actually, I guess we're demonstrating power. So if we want to raise something to the nth power, we have two numbers we need to deal with. We have the x and we have the n. X is the base and n is the power that we're raising it to. I'm moving my slides around, which is why oh shoot. Sorry. All right, give me one sec. Slide, slide, slide. Window, 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 window. Window, 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 window. Window, 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 window. Window, 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 window. Window, window. Okay. So if we have a mathematical expression that we would like to execute, such as b, didn't work. Okay, b times 1 plus r over 100 raised to the nth power. In mathematical notation, that might look good there, but what we actually want to do is to convert that into a linear expression, and that linear expression can be represented as the code below it, in which we take all of the different expressions, we determine which order we want them all to be run in, and we put them in that particular order in our code. I'm sorry, the windows are moving around again in the wrong way. There we go, perfect, perfect. All right, almost perfect. I'm too OCD for this job. Okay, b times math dot power, where we pass in the power. The first parameter is 1 plus r divided by 100, and the second parameter is n. So the power method works by taking the first parameter and raising it to the second parameter. Notice we have the issue with the division there. Are we going to be creating integer multiplication, or are we going to be doing floating point are we doing integer division or floating point division with that r/100? The 100 is an integer. That's treated as an integer literal by Java. And so whether or not this is integer division or not depends on the type of R. We don't have enough information on this slide to know whether or not R is a double or whether R is an integer or one of the related classes. And so we don't know just by looking at the slide whether or not it is going to be integer or floating point division. The nature of math is such that we really want that to be floating point division, just the nature of running a formula like this. And so if I were writing this code, I would have gone ahead and made it 100.0, and that way it would force it to be a floating point division regardless of the type of R. But R better be well, I guess, yeah, I would have made it 100.0. End of story. All right, and the way we arrive at that is we start at our innermost expression and we, go ahead. Okay, double broadcasting for a second, and now single broadcasting. So we had a question about whether or not Java does order of operations, and Java does respect order of operations as it understands it. All right, so we convert our expression to linear kind of expression, and then there are all kinds of different mathematical operations that we can run. Square root, power, sine, cosine, tangent, round, ceiling, all those different examples. And one of the ways that you can really quickly see that is just by writing some code. So if you let me create a class that we can just demonstrate this in. I'm going to create a demo class in Eclipse. I'm going to create a main method. I'm going to hit finish. I'm going to open up the demo class in Eclipse. I'm going to zoom in so that you can see it a little bit better on YouTube. And what I want to demonstrate is just that we can call math dot, and you can see the list of all the different static methods that are available to us. We have everything from floor and division. We've got tangent and log. We've got floating point remainders, max and min, multiply, negate, power, random, rand, all kinds of different stuff that's available to us. And we can just call those with whatever we are interested in executing. Question, double broadcast. I, Sorry, I know that's super annoying. It's very, very slightly funny to me, but it shouldn't be because I know it's super annoying to you. Keep me honest. Okay. All right, heading back to our slides. We got a bunch of mathematical methods that are available to us, and the ones that you expect are there. Sometimes it's important to be able to know how to convert one kind of a number to another kind of number. There's a bigger kind of process involved called casting. And what casting means is it's the process of converting one type to another type. Generally, we say we're going to cast one object to another type if we are going to change it into something else. And I guess you can kind of think of it like casting a spell, like some kind of Harry Potter spell. What's the Harry Potter spell that like you change something into like a frog or a toad or pig or something? Um, it's like that. You're going to transform something from one thing into another thing. I don't actually know if the etymology of cast comes from a spell cast, but kind of seems like that right now when I'm looking at it. So if we want to convert one to another, there are a couple ways that you can achieve a particular result. To transform one type to another, you can do that, and you do that by putting the type in parentheses next to what you want to cast. So let me give you an example here. The compiler by itself won't allow you to assign a double to an int because it's dangerous for a bunch of reasons. A double, again, is a floating point number, and an int doesn't have any fractional component. So one way it's dangerous is that you have a fractional part that's lost. Another way that it's dangerous is double can represent numbers that are larger than what an integer can represent. So the magnitude of the double might be too large to store in an integer. And then finally, you just might be making a mistake. You might not be intending to do this. And so the compiler won't allow you to do it. So this code here in the yellow box where you create a variable called balance, which is of primitive type double, and you initialize that to total plus tax, and then you create an integer variable called dollars, and you try and assign that equal to what balance has, you're going to encounter an error because it's a type error. So if we look at that in Eclipse and we just set up something, I'm not going to do exactly what we have there. We get an error because you're trying to force a double to be an integer. The error says type mismatch, cannot convert double to int. All right, but there are times when you just want to do that and you want to force it, even though you know you're going to lose fractional part, or you know you're going to lose, you could run into a magnitude problem. And so the casting operator, generally speaking, is to put in parentheses in front of the variable or the amount that you want to cast, and you want to put the type you want it to be transformed into in those parentheses. So in this case, what we're doing is we are saying, hey, I know that's a double. I want it to be an int. I recognize the danger that I'm walking into by converting something that possibly can't be represented correctly. Do it anyway. I'm the programmer. I'm in charge. Back off. So the compiler says, whoa, just quit exerting all your toxic masculinity on me. Toxic programmerness, I guess, because you could do that even if you're femininity. your toxicness, masculinity or femininity, and just assign it an amount. Eclipse responds by saying, okay, and then it gives me an unrelated warning, which is, hey, you're not actually using amount anywhere. So you can do it that one way. That's probably not the right way to do it, though. Because that discards the fractional part, you don't often mean to do that. Instead, what you want to do is you want to do it properly and mathematically. But I introduced that because you can do a lot of different kinds of casts. You can cast in different ways, and if there is a mechanism for Eclipse to do it, it will allow you to do it. So in some cases, you might cast to a particular class. We haven't seen a reason to do that yet, but you can do that. But for the time, but Eclipse doesn't know how to do that, and so it's going to error out. Syntactically, it's okay, but procedurally, it doesn't know what to do. So you can do it with other types, but in this case, we're just looking at it with a number type. Let me clean that up. All right. So in the bottom there, you see the general process of casting. Cast with whatever your type name is, and then convert it to a different type. Now, probably more likely what you want to do it the correct way is to call the round function, which is a static method of the math class. And in this case, what we're going to do is probably what you intend to do, which is to take a floating point number like balance and convert it by rounding it mathematically to some kind of integer number. And what math.round returns is a long integer because it wants to, as much as possible, avoid overflow errors. Now, it's still possible for a floating point number to be larger than what can be represented in a long, but you can represent more integers in a long than in an int. And so this is going to take something like 13.75 and round it to 14. If you were to cast 13.75 to a long, you would end up with 13 because the casting doesn't do rounding. The casting just throws away a fractional component in a way that integer division does as well. So you just have to be careful and you have to be aware that it might not be doing the right thing that you want. And if you can't remember what it's going to do, it's easy enough to just write a simple test code, create a class like I just did with the demo class, create a main method, and just write a little bit of code that explores what happens in the particular cases you're concerned about. Create a couple variables, do the example, and then do system.out.println. I would say that when I'm in like coding mode, I will do that kind of work maybe, once every couple hours because I don't remember the exact details of how something works. And it's not something that's documented, it's something that's part of the Java language. So I need to either look it up in a textbook or sometimes it's faster to just test out what I care about. Checking in on questions. Okay. All right, so that's a cast. Bunch of arithmetic expressions. I feel like I don't want to exhaust this too much. Here's something I did want to introduce you to. This was to address the question that we just got, which is, does Java respect orders of operations? It does. However, you can see that formally there are 14 different categories of operations that Java recognizes. And so, for example, you can see that addition and subtraction is in category 4, and multiplication, division, and remainder or modulo are in category 3. And what this means is that if there are no parentheses, anything in a higher category will be executed before something in a lower category. And this reminds you about how many different kinds of operators there are in the Java language and how there are specific rules for how all of these different priorities are handled. And one thing that one of the reasons why I use parentheses liberally is because it has the highest priority. You see that up here we have parentheses listed to evaluate things as well as to do method calls. But when you look down here and you look at, for example, category 3, times, division, and modulo, you can see that the priority within this class is equivalent. And so the things that happen first are the things that the compiler encounters from left to right that are in this priority. But notice that it's not the same for the category above. For the category above, everything in this category is done from right to left in priority order. You can see the typecast is there, object creation is there, bitwise operators, postfix and prefix increment. Okay, so that drives me nuts because not being able to remember what's in every category and whether we're doing priority from right to left. Now, Java will respect all this, and if you want to memorize it, great, more power to you. Maybe that's something that comes naturally to you. It does not come naturally to me. And so I just put parentheses around everything and don't worry as much about remembering all of these categories. Some of them are like relational operators and if statements are just work really well with these operators. All right. All right, so let's see. The last, without doing these self-checks, the last bit to go over, I want to do one more thing in Saros. So let me just, let's see, I don't want to belabor everything. What is the most important thing that we talk about in the lecture? Let me just draw your attention to a few things that you're going to have to look more carefully about in the textbook. One is getting input from the user. We've seen system.out.print. That's a way of outputting to a user. We can take input in from a user by using a scanner class and system.in. So you can relate system.in to system.out. Out takes something, puts something on the console. If you pass system.in to a scanner, you can read things in from the console. And the way you do that is you create a variable called in, and every time you ask for the next type, the console will bring it to you. Let me make you aware of that. And make you aware of one more concept, format. If you want formatted output, we have the ability to do that. Yeah, that's not what I'm showing. I want to show you this one. It is the same way that we did formatting in Python. We use these characters in strings, same tokens, percent, and then an F for a floating point. The number of characters we're going to reserve for the digits, and then the number of characters we're going to reserve for the fractional part. And then we pass as a second parameter the price parameter here. All right, and then finally, there's some discussion in this text, in this chapter about strings. Strings and characters, we've used them a lot. So it's very similar to the way that, what do I want to show you? It's very similar to the way that strings work in Python. You can create a string literal. You can pull one particular character out by asking for the character at a particular location, and then you grab it. But the reason why I'm trying to rush through this is because I feel like these things you're going to pick up very fast with your background in Python. And what I want to do right now is I want to share a different project with you that's a little bit more fun and gives you a little bit something to work on. We're going to look at it more in depth when we do our looping chapter. So what I'm going to do is I'm going to I'm going to switch to showing you the desktop for starters. And I'm going to break our current Saros session. So here we go. I'm going to break it. And now you have the ability to turn in the daily work once you edit it as appropriate. I'm going to share a different project with you. This is a large project and it's going to take a little while to run. And so before I do that, I'm going to show you what the output is because it's going to be a little chaotic when I share it. If you run the class called environment in this as a Java application, it will open a library called jMonkeyEngine, which is a graphical environment. And you can create games or whatever you want to do. So this is a Java environment. It looks a little bit like our virtual world, but this is code that is being written by us. And so there's a little box there in a world with some textures that I've created that I've used as well. And so we have the ability to do different kinds of things to change that. Let me really rapidly do this. Oh gosh. Feeling the time pressure. Okay, that's taking too long. So I'm going to share this project with you now so that you have a copy of it. Here we go. Whoosh. All right, jMonkeyEngine demo, great. All right. Now you're gonna have to, this is gonna be chaotic. Here we go, chaos. Feel the chaos, love it. It's a much bigger project, so it's gonna take a little while to download everything. Although actually Saros just made some changes so that this kind of sharing happens faster, and I can see that in fact that just did happen. So don't edit anything yet. If you have the project and you want to go under SRC and edu-westmont.cs30 and you want to run the environment project to see it work on your computer, you can do that, but please don't edit any of the source code until I can switch you all to read only, and then you won't be able to. All right. I'm watching the code get transferred to y'all, and some of you are on some pretty constricted connections, so it's just going to take a little bit. Give me a shout out if you're able to get the box, if you're able to get the application running that shows the box spinning around on the grass. So on my side, it looks like Ben D. It looks like it's waiting for you to accept the invitation. That might be a computer issue, not you. Same with Dee Dee. Um, I'm synchronizing the project with several of you, although it doesn't show me whose name it is synchronizing with. I'm going to switch to broadcasting in game. Okay, I'm broadcasting, double broadcasting game and on screen, single broadcasting on screen. And thank you. This has been February 5th, Friday. We have been working with Java and JavaDocs. This ends our broadcast for today. Yay.